Dear students, in this module, you will learn about the project evaluation or program evaluation. After studying this module, you shall be able to learn different methods of program evaluation. You would come to know the difference between quantitative and qualitative approaches to ex ante and ex post approaches, about selection bias in participation can confound the amount of treatment effects, and different methodologies in impact evaluation, including randomization, propensity score matching, double differences, instrumental variable methods, and regression discontinuity and pipeline approaches. Also able to learn to apply program evaluation techniques. Let us introduce the subject. Interventions and social programs by public sector call for huge amount of resources that can be spent for alternative programs. These costs are much higher in the developing countries, where the required means to satisfy the wants are more scarce. An evaluation of the impact on costs and benefits, therefore, is imperative to determine the effectiveness and justify implementation of the interventions. As Heckman et al. In 1999 puts it, an emphasis on the publicly accessible evaluations is a distinctive feature of the modern welfare state, especially in an era of limited funds and public demands for accountability. The literature on evaluation methods in economics is huge and continues to grow. Bundell and Dias 2002 gives the summary of this. Most of the earlier evaluation in economics were done in the areas of labor market and social safety net literature, with seminal works by Ashenfilter and Card, and Heckman and Raub in 1985. Let's look at the aspects and elements of program evaluation. What is program evaluation? Let us try to understand this. According to OECD 1999, program evaluation encompasses various types of evaluations: policy, level evaluations, concurrent assessments, rapid appraisals, and beneficiary assessments, and indicator monitoring. Program evaluation is a tool which is used to determine the costs and benefits associated with projects. There is a difference between the objectives of program evaluation. However, each evaluation aims to quantify the aspects of the program. It is known as impact assessment in many cases. The important aspect of an impact assessment is an estimation of the effect on program participants that can be attributed to direct participation of the beneficiaries in a program for intervention. Its objective is to determine if the program can achieve its stated goals. The impact evaluation would answer the following questions about a program. Does the intervention or program achieve the targets? Does it have unintended effects on participants? Whether there is a difference between the impacts of program among the individuals. Whether the program cost is effective in comparison with other options. Also, the reasons for success or failure, and what can be recommendations or remedial measures to improve the performance of the program. Now, conducting an impact assessment requires a plan that A. establishes evaluation objectives, 2. determines the necessary and appropriate evaluation methods, C. provides a data collection strategy and identify available sources, and 4th, establish a timeline for producing and disseminating finding. Let's look at the objectives and outcomes. The principal objective of any evaluation is always to find out does the program is helpful or is helping beneficiaries or not. It is important to find out whether the program has targeted the right set of people or not. This is mainly the case for developing economies because there is a scarcity of resources and the amount of leakages are generally larger. There should be the proper question on policy which should be clearly answered against all the points such as constraints on resources, which include money, time, and availability of data. Moreover, all the features which are to be analyzed, the time period over which the analysis is done, and the outcomes to be found out should be specified in the objective statement. For example, in order to find out the impact of a health and education program, clear outcomes in the context of grade school annual attendance, annual sick leave, immunization rates, etc. should be specified outcomes. Programs also need to be evaluated in view of directly targeted beneficiaries as well as the ones that are affected indirectly. This will include finding out all the effects by considering the externalities of the program. Let us understand the program costs in this section 3.3. There is high cost involved in the program. In case of developing economies which have scarce resources, an evaluation of efficiency of program becomes imperative. The valid estimates of cost are important for the evaluation of policy interventions. There has not been as hugely empirical study in estimating costs or efficiency of programs as has been in estimating effects or effectiveness or efficacy of interventions. Due to the involvement of problems, indirect cost is neglected and only direct cost is taken. Smith 1999 suggests that there should be three components in the cost of program participation, that is, the time cost of participation, the time cost of program delivery, and the financial cost involved in program. The evaluation problem in section 4. 4.1, the formal evaluation. In recent years, the evaluation literature in statistics and econometrics has developed a unified formal framework that facilitates the exploration of the potential and the limits of both experimental and non-experimental evaluation strategies following Rubin 1974. Any impact evaluation attempts to answer essentially counterfactual questions. That is, how would individuals who did benefit from the program have fared in the absence of the program? How would those who did not benefit have fared if they had been exposed to the program? The problem is in answering this question is that the same individual cannot be observed simultaneously on both the situations. An individual is observed either exposed to the program or not exposed. Comparing the same individual over time in most cases will not give reliable estimates of program impact, as many things would have changed. We therefore cannot seek to obtain an estimate of the impact of the program on each individual. The only possibility is to be able to obtain the average impact of the program on a group of individuals by comparing them with a similar group that was not exposed to the program. Thus, the prime objective of impact evaluation is to establish a counterfactual or comparison group who, in the absence of the program, would have had results if they were exposed to the program. Treatment effects need to be estimated. The average effect on individuals of a specific type would be population average treatment effect, or ATE, which is the outcome if individuals were assigned to treatment and the effect of treatment on untreated, or TU. Blundell and Dias 2002 lay out the formal evaluation problem. If a policy intervention at time t for which we want to measure the impact, the outcome variable is y. This is assumed to depend on a set of exogenous variables x, the particular relationship being dependent on the participation status in each period t. Let d be a dummy variable that represents the treatment status, assuming the value 1 if the agent has been treated and 0 otherwise. The outcome equations are represented as follows. I is equal to st1 into xt plus mu it1. Similarly, yit1 is equal to st0 into xi plus mu it0, where the superscript stands for the treatment status and the subscripts I and t identify the agent and the time period respectively. The functions S0 and S1 represent the relationship between the potential outcomes Y0 and Y1, and the set of observables X and mu0, mu1 stand for the error terms of the mean 0 and assumed to be uncorrelated with the regressor X. The X variables are not affected by treatment or predetermined and are assumed known at the moment of deciding about participation. For comparison purposes, this means that agents are grouped by X before the treatment period and remain in the same group throughout the evaluation period. It is assumed that participation decision can be parameterized in the following way. For each individual, there is an index IN depending on a set of variables W for which enrollment occurs when this index rises above 0. That is, INI is equal to a function of Wi plus Vi, where Vi is the error term and DIT is equal to 1 if INI is greater than 0 and T is greater than K. DIT is equal to 0 otherwise. Except for experimental data, assignment to treatment is mostly not random. As a consequence, this implies a non-zero correlation between enrollment in the program, represented by DIT, and the outcomes error term, or U0 and U1. This happens because an individual's participation decision is probably based on personal unobservable characteristics that may well affect the outcome Y as well. If this is so, and if we are unable to control for all the characteristics affecting Y and D simultaneously, then some correlation between the error term and the participation variable is expected. Any method that fails to take such problem into account is not able to identify the true parameter of interest. Under the above specification, one can define the individual specific treatment effect for any xi to be alpha it into xi is equal to y1 it minus y0 it. This is equal to git into xi minus g0 t into xi plus mu1 it minus mu0 it with t greater than k. The different parameters of interest measured in period t greater than k then can be expressed as average treatment effect equal to alpha ate equal to expected value of alpha it given x equal to xi. average treatment on the treated effect can be written as alpha TTE equal to expected value of alpha IT given x equal to xi and dt equal to 1. Average treatment on the untreated effect is equal to alpha TU equal to expected value of alpha IT given x equal to xi and dt equal to 0. Having laid out the formal problem, we now turn to the methods that are used to estimate impact. So let us try to understand the methods in our section 4.2. 4.2.1, we have the experimental studies. The primary objective or the prime objective of any experiment is the randomized assignment of individuals into treatment and control groups. It eliminates bias in the estimates of impacts. These biases are a result of the ex ante differences that exist between treatment and comparison groups and get enhanced with the effects of program participation. A completely random assignment of individuals into a treatment group and a control group ensures that any observed differences over time between the groups will be due on an average to participation in the program. There are two conditions that are needed to ensure that random assignment does away with pre-existing differences between treatment and control groups. First, the assignment procedures must be truly random and the process should not affect the program itself. And second, control group should be exposed to the program or a similar program. Though there could be cases where control groups refuse to participate or deviate from normal behavior, Heckman et al. 1999, still randomization is the preferred evaluation methodology. Despite the superiority of randomized experiments to ensure best estimates for impact of interventions, they may not always be feasible due to the high costs and detailed planning that is required for them. There are also ethical issues in denying intervention to a certain section of society. Let us now understand the non-experimental or observational studies in 4.2.2. If random assignment is not possible, then the ex post data shows how individuals responded to an intervention. The objective of any evaluation study is then to use this information in an appropriate way so as to replace the comparability of treatment and control groups by design. In the case of non-experimental studies, data can only be observed after participation and no prior knowledge exists about the treatment group. These studies then are more demanding in terms of the estimation techniques that are evolved to account for missing information. The non-experimental methods can be categorized as those that primarily address bias due to or observable characteristics, and second, those concerned with bias from unobservable, including multivariate regression model, reflexive comparison, and double difference and instrumental variable methods. Multivariate regression is used to account for possible differences between participants and the comparison group on measurable characteristics. Measuring the program impact on outcome, holding all the factors constant is used for this. The parameter of interest is the marginal effect on the outcome of participation in the program, netting out the effect of other characteristics. In principle, if all characteristics that affect the outcome could be measured and included in the regression, it would produce an unbiased estimate of the program impact. The multivariate regression model forms the analytical framework used in most impact evaluations. However, if there is bias due to endogenous program placement or due to selection, then the regression estimates could not give correct estimate and more robust techniques are required. Another technique is matching. A matched comparison is formed by selecting individuals or households that are very similar to the participants group using measured characteristics. The principal idea of exact matching is to assign to one or more of the individuals in the intervention sample as matching partners for one or more individuals from the non-experimental control sample who are similar in terms of their observed individual characteristics. The method used for matching is propensity score matching. All observed characteristics are used to predict the likelihood of program participation. The non-participants are then matched with participants for closest propensity score. The impact estimate is the difference between the mean outcome of the participants and the comparison group mean. Let's look at another method which is known as difference-indifference method. The double difference method attempts to eliminate bias from unobservable characteristics when the comparison group is externally selected. The idea is that the treatment and control group differ from one another mainly in ways that are not observable, but these do not change over time and can be subtracted out from an estimate of program impact. The impact estimate is the difference between the before and after program change in outcome for the participants, which is the first difference, and the before and after program change outcome for the comparison, that is our second difference. So under the assumption of a fixed unobservable difference between the two groups, the difference-indifference method provides a consistent estimate of the overall program impact. Let's look at the instrumental variable or IV method. Using the regression model, the outcome variable is regressed on the indicator of program participation and other variables that affect the outcome. If participants and comparisons differ due to unobservable characteristics and these are related to program participation, then the program indicator variable is correlated with the regression disturbance term, yielding a biased estimate of the coefficient, the program impact. An instrument would be a variable that's highly correlated with program participation but not related to the outcome. Before and after comparison is another method. Probably the most common evaluation strategy for attempting to construct a counterfactual is a comparison of treated individuals with themselves before and after an intervention. The comparable non-participants then are the participants themselves before the program was implemented. This requires longitudinal data. Let's look at the cross-section estimates. In before and after comparisons, program participants serve as their own controls. Due to the lack of longitudinal data, cross-section data is used to arrive at program effect estimates. Here one needs to take the means over the corresponding observations in random samples of participants and non-participants and estimate impact of intervention. We have a box which shows what is a selection bias here. This selection bias relates to unobservable that may bias outcomes. For example, individual characteristics, pre-existing conditions, etc. Randomized experiments address the problem of selection bias by creating an experimental control group of people who would have participated in a program but who were randomly kept away from the program or treatment. The random assignment does not remove selection bias, but instead balances the bias between the participants and non-participant groups. In quasi-experimental designs, statistical models, for example, matching, double difference, instrumental variables, approach this by modeling the selection process to arrive at an unbiased estimate using non-experimental data. The general idea is to compare program participants and non-participants holding selection processes constant. The validity of this model depends on how well the model is specified. For example, in the case of labor market for women, the data shows the number of women who choose to work. If this decision were made, we could ignore the fact that not all wages are observed and use ordinary regression to estimate a wage model. Yet the decision by women to work is not made randomly. Decision is dependent on some pre-existing variables. So women who would have low wages may be unlikely to choose work because their personal reservation wage is greater than the wage offered by employers. Thus, the sample of observed wages for women would be biased upward. This can be corrected by considering variables that strongly affect the chances for observation, in this case the reservation wage, but not the outcome under study, the offer wage. Such a variable might be the number of children at home. The box has been sourced from or adopted from Green 1997. Let's now summarize what we have learned in the module. We have learned that program evaluation has become an important tool to assess effectiveness and efficiency of programs. Its initial applications in the labor market have provided useful insights into how programs should be designed and implemented. The estimation of effects in experimental studies does not involve the problem of bias. However, most of the interventions are quasi or non-experimental, and the bias needs to be corrected by use of robust econometric techniques. We have a table which is summarizing the case studies of interventions. We have different countries and the programs which were launched by them and the program experience. I'm sure you can all look at this table and try to learn from these countries' programs and their outcomes here. We also have a table 2 which gives you the outcomes and resources in selected programs. You can look at the countries, their programs, and what are the outcomes. For example, in Tanzania, the program of Iringa gave us an outcome of underweight, which means our objective was to look at the underweight children, and we saw reduction from 50 to 35% between 1984 and 1988. The immunization was there, and this immunization increased from 50 to 90%. So we have very many other examples. For India, we have the example of ICDS, where overall underweight prevalence declining only slowly. Some states reported faster, but link to ICDS was not shown clearly by this program in terms of outcome. Thank you very much.